L1 by Y1. I'm not saying F1 by A1 because F by A is same for both the rods. But length will be different, Y will be different. Is that okay? X equals so much. Can I say equation 1? Similarly, I'll land on top. For rod 2, what is X equal to? Complete.
Compression minus thermal expansion.
Yes. The compression is more than the expansion, therefore rod 2 contracts. So this is equal to mechanical compression minus thermal expansion. So what is the mechanical compression? Dictate. F by A L2 by Y2 minus, yeah, alpha to L2 delta T. Yeah, here is your equation 2. Equation 1, equation 2, and you have got two unknowns. X is one unknown and F by A, the stress, is another unknown. Eliminate F by A, solve for X, that's your answer. Two equations, two unknowns. Finish it off. You can get your X. I can recall a few things in the answer. So I think L1, L2 delta T is there. Then there is some numerator and some denominator. So let me know what they are. Alpha 1 Y1 minus alpha 2 Y2 upon L2 Y1 plus L1 Y2. Yeah, is that it? L1 L2 delta T into alpha 1 Y1 minus alpha 2 Y2 upon L2 Y1 plus L1 Y2. So that also indicates that if this is equal, then X will be 0. There can be a situation where blue and the red kind of have an equal push against each other, nobody moves. Or if alpha 2 Y2 is more, then it will be negative, which means the red will dominate. This will go to the left. Yeah? Is this question fine? Rather, now let us take up that question which you asked me from H.C. Verma. Is this to be done somewhat similar to this? Let us see. You got a aluminium plate which is sandwiched between two steel plates. So to say, I can call it a trimetallic strip if you want. I'm just saying because we have done a bimetallic strip, so I'm calling it trimetallic strip if you want to call it that way. So in the bimetallic strip we had seen last time that what happens when you increase the temperature? It will kind of curve on one side. The one which has the greater alpha will take the outer circle and the lesser one will take the inner circle. Now what do you think is going to happen here? They are all bonded together. They got to grow together. Aluminum can't go beyond steel or any one of that. No, they can't move. You don't say that they will buckle. They won't go like this. Okay, this won't happen.
Yeah, this won't happen.
So they got to be saved. So nothing can happen. They cannot bend towards any one side because both the sides are symmetrical. Yeah. So let us assume just for the heck of it that alpha steel is more than alpha aluminium. I don't know which one is more. One of them got to be. And what is also given to you is the length of the strip L0, Y steel and Y aluminium. These are the, okay, A is aluminium, S is steel. This is the data given. And you have to say that when temperature increases, delta T, what is the new length or what is the increase in length of this whole sandwich, so to say. It's an aluminium sandwich between the slices of steel. Now, as such, when they expand, suppose there is the extension, let us say, is X. Now, if steel were independently there, will it expand more than X or less than X?
More than X.
More than X. And what about aluminium?
Less than X.
Less than X, that's right. Because so now what is going to happen here is, since aluminium and steel are together, the steel would like to freely expand, but aluminium will try to pull it back. Likewise, aluminium expands, but steel would like to pull it forward. It is something like you are running with a child alongside you. Now your speed is much greater than the child, but if you have to hold the hands of the child and run, the child will be dragged by you forward and you will be dragged backwards by the child. So both of you will have to come to some compromise. Okay. So something like that is happening between the steel and aluminium. So I make a free body diagram for the steel. Free body diagram for the steel. Look here. I'm making it here. On the steel, steel will be pushed inwards on both the sides by aluminium. I'm calling this force as F by A. Can you see it? So the steel is pushed inwards. And what about aluminium? Free body diagram for aluminium. On both the sides, because it is on this side there will be action reaction. This is F by A on top also, and there will be F by A and bottom also. The aluminium is being pulled outside on both the sides, on top surface as well as bottom surface. Now whatever is true for this steel, the same thing is true for the bottom steel. I don't have to make it because that is symmetrically so. Is that fine? Now what will you call this? This is the particular kind of stress. Do you know what to call this stress?
Shear stress.
Yeah, that's right. Why are these pages buckling? I'm applying a shear stress. Now if you apply this way, this is pressure. That's normal stress. Okay? When I apply like this is tangential stress, is called shear stress. Now, for example, how do you apply cream on your face? Like that? That's shear stress. You don't put cream and then press it. It's not pressure. Okay, so for cream or massage is shear stress. Okay, and injection is pressure. So we are talking about shear stress here. So my question is, on the steel, the shear stress is what? 0, F by A, 2F by A, 3F by A. Whatever. Tell me, what is the shear stress on steel?
2F by.
And on aluminium?
4F by.
Now forget about this. Look here. I have a wire and a weight is hanging from a string. Now I draw the free body diagram of the wire only. I will say on the wire, two forces which I am calling as tension are acting like that. Is the free body diagram of the wire okay? What is the tension acting on the wire? 0, 2T, 4T, what?
T.
T. Why are you saying T? If this is T, then what is this?
F by A.
Yeah, if this is T, then this has got to be F by A, but you said 0 here. Why? Did you? Okay, I'm sorry, you said 2F by A, right? Yeah, then the tension should be 2T here. What is the tension? What does tension mean? Tension is not acting at any particular point. Tension means you take up any segment. If you make a cut section there and you ask what is this force, the answer to that is the tension. So you will say net force is 0, so F must be equal to T, so F is equal to T. Like that, if I make a cut section here, and ask you what is the force here. So you will say, because it has to be in equilibrium, this 2 must be F by A. So stress on this is F by A.
Stress everywhere in here.
So stress everywhere on the steel plate is F by A. Is it compressive stress or tensile stress? Is it a compressive shear or a tensile shear? Is it trying to drag it out or push it in?
Push it in.
Push it in. It's a compressive shear stress. We can say like that. So the shear stress on steel is F by A. What about the shear stress on aluminium? 2F by A. Finish. 2F by A. So now we are on to the last stages of our discussion. So now let's go back. I'm redrawing this picture. So let us take X. For steel, when you talk about X, the X stands for what? I'm talking about the net extension. The net extension comprises of what phenomena and what it is. X equals thermal expansion. What will it be?
Thermal expansion minus mechanical compression.
Thermal expansion minus mechanical compression. That's right. So what should I write? X equals, dictate. What is thermal expansion equal to?
Yes,
Alpha steel L naught length of steel is same as that into delta T minus thermal compression, mechanical compression. What is the formula for mechanical compression? By Y steel. The F by A is, let us say, F by A, the stress. L naught is the same upon Y steel. That's the formula for steel. Okay. Now, what can we say for aluminium? I'm taking this as from equation 1. For aluminium, X equals what? Aluminium is having mechanical compression, or what is it having? So what will you say? Why minus? Why minus? Aren't both of them in the same direction? Expansion, whether it's thermal or mechanical, both are additive. It's expansion, so why are you subtracting it? It is thermal expansion plus mechanical expansion. Both phenomena are additive and both of them will happen together. So what is the thermal expansion equal to? Alpha aluminium L naught delta T plus, complete the equation, 2F by A. That's right, if the stress is 2F by A. 2F by A L naught upon Y aluminium. Okay. Once again, you have two equations, two unknowns. Eliminate F by A to solve for X and get your answer. You are able to get that answer, I think. Yeah? Yeah. Yeah, of course. A delta T is also there. So there will be 10 questions here. So you solve it and can refer to your notes. Just note down 1A, 2B, 3B, whatever your answer is. At the end of it, I'll give you the answers. You can correct it yourself, get your score, and we can also discuss the questions. Okay? So I'll be able to flash you one question at a time, and I'll ask you whether I should go further or not. So accordingly, I'll go further. So about 2 to 3 minutes each question I will flash on the screen. You can always ask me to get back to a question if you want. So shall we start now? Are you ready? So those are the marks for the question. The first 6 questions are single answer type. You have 3 marks each, and actually it is 3 negative 1. The negative 1 is not mentioned here. The 7th question is a more than one correct, one or more than one correct, which is 4 marks. And 8 to 11, it's a comprehension question where 2 marks are there for each of the 4 questions. So here we go. The first question now. Shall I go to the next question? The degree centigrade, the power is, it is not C minus 1, it is C power minus 1, degree per degree centigrade.
That's
3x plus 2 into 10 to the power minus 6. Again, minus 6 is not given as power, just make that correction. Also the A is missing for the first choice. A is 2.124 meter. Yes, shall we move on?
Yes, sir.
Yes, sir.
Anisotropic is opposite of isotropic. Isotropic means it is same in all directions, and isotropic means different in all directions.
So next question.
The final, it is saying composition rod, it should read composite rod equals the average coefficient of lead expansion of the composite rod equals what? Yeah, shall I go ahead? That R is rho, density rho, coefficient of thermal expansion alpha, and Young's modulus Y. Yeah, shall I move on? See, the water on one side is 4 centimeter below than the other side.
Okay.
On one side is 120, other side is 124. The difference of height is 4 centimeter. On the left it is 120, on the right it is 124. Yeah, shall we move on?
Yes, sir.
M stands for more than one correct. This question and the next 3 questions are based on this cube floating in a liquid.
Yes.
All the last three questions are here. So this is the marking scheme, and you have the, I'll write down the key here. So question 1, the answer is C. Question 2, the answer is C again. Question 3, answer is C. Question 4, answer is C. Question 5 is C.
No, why is everything? I don't know.
Question 6 is C.
No, why is everything C?
7th, A, C, D. 8th one, D. 9th one, A. 10th one, A. 11th one, A. Find your score according to that. Plus 3 minus 1 for the first 6 ones. Then plus 4 minus 1, and then plus 2 minus 1. Okay, fine then. Alright. So tell me, which are your doubts here in this? We'll discuss that.
Second.
Yeah, tell me which questions. Which questions you want to discuss? Second. Then what else? 5th, 11th one. Then 6th one. What else? 3rd one. Then what else? Also the 10th one, is it? Okay, so let's have a look at the second one first. If you look at the rod, at any distance x, if you take a small element dx, now this dx will expand by some amount. Let me call that stretch as the little amount by which it expands. I am calling it as ds. The d, I'm using a new symbol as s because x is already involved. This is the extension delta L will depend upon alpha, the original length, delta t. Alpha is a function of x. So you get 3x plus 2 into 10 to the power minus 6. Delta t is how much? Delta t is 0 to 20. So this is 20 into 10 to the power minus 6 is from here. I'm putting it like that. Now this is your stretch at distance x. Now if you want the total stretch, each of these rod is made into an element. Each element stretches by some amount. So the stretch, if you add up, the net stretch will be this. X is ranging from 0 to, it is asked in centimeters, so it is 0 to 200. So perform that integral and see whether you get the C answer. I mean, this will give you the extra part, that is to say the 0.012 meter. It should be in centimeter. This is in meter. X is measured in centimeters, so in centimeter it will be 1.2 centimeter. So just check if you get 1.2 centimeter for this question. The third question we proceed to. Third one. See, notice that now here you are having, I will just justify why the correct one is correct. The C part, if you notice, we are talking about the, can we have the C question please? See, look at the C question. Now the side, the one which we are talking about is side CDEH. Now CDEH consists of which two sides? CDEH is parallel to the X and the Y. So shall I say the new length XY will be equal to X naught 1 plus alpha X delta T and Y naught into 1 plus alpha Y delta T. Right, like that. Now XY is equal to X naught Y naught. Now here I have put alpha X delta T, alpha Y delta T. If you multiply, this becomes alpha X plus alpha Y delta T. Alpha X into alpha Y delta T will be too small. We'll neglect this. So if you compare it, this is your beta. Beta equals alpha X plus alpha Y. You will notice that we are getting that as the answer. Alpha X plus alpha Y. See, alpha X is 1 and alpha Y is 2. 1 plus 2 is 3. 3 into 10 to the power minus 5. None of the other answers, this logic will click. You can check that out also. So C is the answer. Is that okay? Yeah, is it fine?
Yes, sir.
Yeah. We move on to the fifth question. The fifth question. See, the rod, if it expands, Now the wall is going to prevent it from expanding. How much is the stress on the rod? Stress will be what we have done earlier. The stress is F by A. The F by A is equal to Y alpha delta T. Yeah. Now look at the board. This is the free body diagram for the rod. It will be stressed from, the wall is going to press it from both the sides. F by A is Y alpha delta T. But this F is what is equal, is the same as normal force. And if this is the normal force,